Okay, this video is going to go over the notes for 11.2, finding the volume of cylinders and prisms. So volume is defined as the measure of the amount of space in a solid. And you're going to use cubic units to measure volume, such as cubic centimeters or cubic inches, or you could do cubic meters, cubic feet. In the equation for the volume, B is going to stand for the area of the base. And H is the height or the altitude of the solid. And whether or not it's right prism or cylinder, or it's an oblique prism or cylinder, the volume is still going to be the area of the base times the height. Right? So the area of the base times the height of the cylinder. And here we can see you have a right cylinder, an oblique cylinder, and a right pentagonal prism and an oblique triangular prism. If it's a right, the altitude is just going to be the height of the axes here. However, if it's oblique, the altitude will be outside of the cylinder. And the same if it's an oblique prism. The altitude's outside the cylinder. And, okay. So let's do some examples here. Here we have a bunch of 3 prisms. There are 3 rectangular prisms. They give the length, the width, and the height. So to find the area, first you're going to find the area of the base. Now, the way we define a base with a prism is it's 2 parallel congruent faces. So you could actually have this side and the side in the back be the base if you wanted to. Or you could choose the top and the bottom to be the base. In this case, we'll just do the top and the bottom. And so that would be 2 times 4, which is 8. And the height in that case would be 3. So the volume would be 8 times 3, which is 24. And the units are centimeter cubed or cubic centimeters. In this case, let's actually something different. Let's choose this side to be the base instead of the bottom. We can do that. So the area of the base would be 8 times 3, which is 24. The height then would actually be 12, right? It doesn't look like a height because it's horizontal, not vertical, but that is, if the base is the 8 by 3 face, then that would be the height. And so the volume would be 24 times 12, which is 288 cubic centimeters. And moving on, this time we'll go back to choosing the top and the bottom to be the base. And so the base is 10 times 30. Your height then would be 10. So the volume, and this is 300. So the volume is 300 times 10, which is 3,000 centimeters cubed. There we go. There's how to find the volume of 3 prisms. Let's do some examples. Here it says to find the volume of a right trapezoidal prism that has a height of 10 centimeters. The 2 bases of the trapezoidal measure to be 4 and 8, and its height is 5. Right, so again, the base is 2 congruent parallel polygons, so the base is actually going to be on the side. And your height is actually at horizontal distance. So the area of the base would be 1/2 B1 plus B2 times the height of the trapezoid. So that's going to be 1/2 times 12 times 5, which is equal to 30. Your height then is 10. So your volume, right, is B times H, which is 30 times 10, which is 300. And then we'll put unit, centimeter cubed. And you're done. Okay. Next, to find the volume of an oblique cylinder that has the base with a radius of 6 inches and the height is 7 inches, right? So notice the height is not 9. Height is outside here at 7. So the area of the base is pi 6 squared, which is 36 pi. The height is 7. So the volume, which is the area of the base times the height, is 36 pi times 7. And that's going to be 252 pi centimeters cubed. And that would be the answer if it said to leave it in terms of pi. But what if it said to round to the nearest 0.1? Well, then you would multiply that by pi on your calculator, and you would get the volume would be approximately equal to 791.7 centimeter cubed, right? So it depends whether or not it says to leave it in terms of pi, or, which would be this, or if it says to round to the nearest 0.1, then you would get that answer. Okay. That concludes, actually, a couple more notes. Notice how we skipped chapters 9 and 10, and we're going to do those later. So after we finish chapter 11, we'll go back and do chapter 10, and then 12, and then we'll finish with 9. There's a couple things we learned in 10 that they assume you know, particularly the Pythagorean theorem and special right triangles. So if those do come up, I'll make a note in the homework about that. And so there are a couple notes, there's one note in the homework. And that's going to be my homework video, so you can watch that to get that information. But basically, there's these what are called special right triangles, and one of them is called a 3, 4, 5 right triangle. Now, this is worth memorizing. It's going to be on the SAT, the ACT. Really, you'll see it a lot. So rather than having to do the Pythagorean theorem, if you're given a triangle where one side is 3 and one side is 5, you instantly know the other side is 4. You'll often see multiples of this too, such as 6, 8, and 10. So the hypotenuse is 10, and the legs of the triangle are 6 and 8. Notice 6 is what? Well, 6 is 2 times 3. 8 is 2 times 4. 10 is 2 times 5. So you'll see these triangles quite a bit throughout this lesson. In fact, I believe in number 2 on the homework, it is a 3, 4, 5 right triangle, and so you'll use that to find one of the sides of the triangle to find its area. But I'll go ahead and go over that in the notes. Okay, that concludes 11.2 notes.